Foghorn with another installment of Flight School Academics for this, the 19th of April, 2955 or 2025 if you're stuck in the past. This presentation is part of an ongoing series of academics for the members of the Aurora Republic, the premier role-playing organization in Star Citizen. If you are new to the Aurora Republic or visiting for the first time, let me start by saying welcome. Glad to have you with us. I'd love to hear more from you if you're interested in hearing more from us. We're a lawful good organization focused on roleplay exploration and social interaction, are currently active in recruiting on Spectrum and Discord, of course. All right, tonight we are going on the next in our undergraduate pilot training series for BA100 Charlie basic navigational concepts. We'll hull butt through that. There's a lot there, but we'll hit the highlights and then get on to flying in the verse, going out and goofing off a little bit. Don't expect a huge turnout tonight because obviously it is Easter weekend. So happy Easter to all those who are enjoying the weekend. Okay, overview. We're going to go through Cell Nav, Planetary Orientation, and the updates to Star Citizen's navigation system. We should hopefully hustle through that pretty quick and get to goofing off. So Cell Nav, or celestial navigation, for those we're going to very briefly review some concepts from our larger celestial navigation course, and we'll start with a brief review of spherical coordinate systems, which is how it's done in the real world. So the components of a spherical coordinate system, everybody's familiar with an XYZ, which is called a Cartesian coordinate system. That is not what actually happens out in real world navigation, to include navigation in space. So aviation and maritime and land navigation, including astronavigation, are actually all done through a spherical coordinate system. And there are several components. First off, you have to have an origin, such as a center point of the whole system. That's your 0, 0, 0. A fundamental plane, which will define your 0 degrees of latitude, and the primary direction, which is your 0 degrees of longitude. That is everything is longitude is measured from. 90 degrees up and down out of that plane is the 90 degrees of latitude is the poles, and the circle convention can be left-hand or right-handed. The vast majority of spherical coordinate systems are right-handed. There are one or two that are left. So, and that is just by human convention, deciding whether or not a particular spherical coordinate system is going to be left-handed or right-handed. So the coordinates, the three-dimensional coordinates that you get, is a longitude, latitude, and range in that order. Yes, I know that sounds like it's backwards compared, because the horizontal system, which is what you use to navigate, it's the spherical coordinate system that we use to navigate the surface of the Earth. Typically, by convention, puts it as latitude and longitude, but in an actual, all the rest of the spherical coordinate systems are out there. It actually longitude precedes latitude in the 3 digits. So the way it is measured is you first measure longitude from the 0 degree prime direction over to within the plane, over to underneath whatever the object is that you're trying to coordinate. And then you measure the angle up out of the plane to a ray from the origin pointing to the object. And then you measure along that ray the range out to the object. So that gives you your longitude, degrees latitude, and your range. Okay, so I mentioned that's how spherical coordinate systems works as far as the math goes and as far as the setup and the components are, but what are the ones that are actually in use out here in the real world? So there's basically 5 types, and it all depends on the frame of reference. So the horizontal coordinate system is what we navigate around on the Earth's surface. I know what you're going to say. A lot of people are like, well, that's only a lat and long. Where's the third? Because we're on the surface of the Earth, we just don't say the third one, which would be the radius of the Earth. The horizontal coordinate system is, its point of origin is the center of the Earth. And so the lat and long is measured like you've always heard it and expected it. The range is just assumed to be you're on the surface of the Earth. Obviously, if you are not on the surface of the Earth, say you're in an airplane, Then the third coordinate would be your altitude, which automatically assumes a one radius of the Earth as well. So that's taken out. So if you're at 1,000 feet above the ground, then your altitude would be, or I should say 1,000 feet above mean sea level, then your altitude or that range would just be 1,000 feet, even though you're actually 1,000 feet plus one radius of the Earth to the origin. The equatorial coordinate system is what is used by Earthbound astronomy, so it's basically sort of our horizontal coordinate system, just projected out into space from our equator. So it's the equatorial coordinate system. Our Earth's equator is the primary plane that goes out there, and that works for is what's the primary spherical coordinate system that is used for Earthbound astronomy. So telescopes on Earth looking up out at space. That's the coordinate system that they use. An ecliptic coordinate system is what we use to measure everything in the solar system. So this is actually what is used when we're navigating, back in the Apollo days when we were navigating the Apollo spacecraft from Earth out to the moon and back, and how we've done for sending probes out to all of the different moons and planets that we've sent probes to. The navigation systems on those were all using the ecliptic coordinate system, which instead of using Earth's equator as the primary plane, they use the ecliptic plane of our planets. Pretty much all of the planets in our solar system orbit. Their orbits are all basically in the same plane. That's not 100% true because of Mercury. Mercury's orbit is actually slanted slightly. It's if I remember right, I think it's like 12 degrees out of plane. So it's actually not quite in plane with all of the other 8 or 9, depending on whether or not you want to count Pluto and Charon. The galactic coordinate system is how we would measure everything within the Milky Way galaxy, and then all of the galaxies that are within the observable universe can be plotted on the supergalactic coordinate system. They are all spherical coordinate systems. They all work exactly the same way, with the exception of the horizontal coordinate system. I mentioned that they can be left or right-handed, and it's just by convention, and the vast majority are right-handed. All of these systems are right-handed except for the horizontal coordinate system. That one's actually left-handed. Don't ask me why. All of these coordinate systems, the frame of reference that you choose, you're kind of picking your poison, because there are variations that will have to be accounted for. Specifically with the horizontal, if you were trying to locate something in space using the horizontal system, which you wouldn't, but if you were, then you would have to take into account the fact that the Earth is spinning. So you wouldn't only give a lat long and a range. You would also have to say at this exact location and time on the surface of the Earth, because the Earth is spinning around. The equatorial system has its variation is called nutation, and that's because the Earth is not a perfect top as it spins on its axis. The axis actually wobbles very slightly. I think it's something less than 2 degrees, if I remember right. It's off the top of my head, so don't quote me. So again, any coordinate to say plot where that star is in reference to the Earth so you can find it in a telescope later, you have to also take into a time epoch. In other words, you have to say what time that you took that observation, because that will allow you to mathematically account for the nutation of the Earth's axis. The ecliptic system, which is what we use to navigate around the solar system, has to take into account what's called perturbation. So the Sol system is on the Orion arm, or the Orion spur of the Sagittarius arm of the Milky Way galaxy, and we have other solar systems and celestial structures floating past us, and their gravity interferes with our gravity and all of that sort of stuff. So believe it or not, our orbits around the sun and everything are actually affected by this. It's a very small, slight amount, but it is something that has to be taken into account mathematically. So you have to, so any measurement taken on the ecliptic system has to have a time epoch so that you can math, just like the equatorial, so that you can account for the nutation of the Earth, the ecliptic, so you can account for the perturbation of our solar system as other solar systems fly by us and their gravity interacts with our gravity. And we're pretty sure that on the galactic and supergalactic scales that there's got to be variation there too, but because we cannot get some sort of an observation device like a telescope far enough back away to be able to see the whole damn thing inside the frame, we don't know what that is. We're confident by assumption that everything else has variation, so there's probably a variation there too, but we can't mathematically account for it because we cannot observe it yet with our level of technology. Okay, so that's a lot of very heady, very large astrophysics for the rest of my super nerds out there with me. But I've actually given this briefing, well, every year at least, ever since Star Citizen started, and made my recommendations. I got some interesting information for you. So I've always said, okay, so what should they do in Star Citizen? Because at the beginning they were using a Cartesian coordinate system. They just had an X, Y, and Z, which I was like, whoa, that's Cartesian coordinate system is not good for the real world. A Cartesian coordinate system, an XYZ coordinate system, is only good for teaching children three-dimensional mathematics and introducing them. Once that, the real universe operates in a spherical coordinate system. So I was like, my suggestion for Star Citizen was always, hey, if I was CR for a day, or if I could get him cornered in a elevator at some point, be able to talk to him about this kind of stuff, my suggestion to them would be to just use a customized, make a custom ecliptic system for coordinates in Star Citizen. Just use the center of whatever star system you're in, make the center of the sun, or the binary, or the barycenter if it's like a binary or a trinary star system. Make that the origin. Make it, just build all of the orbits of all of your planets all in the same plane, and call that your invariable plane, your primary plane. Pick a primary direction that way, because it's inside of a computer simulation. It's not, it doesn't matter where you point it. In the real world, the ecliptic systems, the origin is the center of the Earth, and the primary direction is from the center of the Earth pointed back towards the center of the Milky Way galaxy, because therefore it doesn't move. And so you can, in Star Citizen, you could just point it wherever you want. And then after that, everything else falls into place. Most other spherical systems are right-handed, so I would just by convention say it's right-handed. And of course, because it's a computer, if you just don't model perturbation, which I don't know why you would even try, therefore it's not a factor. And that's what I would suggest they would do. So the good news is I've got within the last, I don't know if it was in 4.1 or if it was in 4.0, but at some point in the very recent patches, they have added the ability to look at coordinates on the map, and you will notice that there is a number with a degree followed by another number with a degree followed by a distance. So perhaps a longitude, latitude, and a range. So this appears to me that whether or not what the game is doing in the ones and zeros in the background, if it's actually using a spherical coordinate system, or if it's still just doing Cartesian coordinates and then it's just doing a conversion before it displays it to us, okay, that's a possibility. I don't know. But at least what I'm seeing here looks like we're getting a three-dimensional spherical coordinate system for something like an ecliptic coordinate system for Star Citizen. This looks like, to me, like how it's working. Now, based on the numbers, it doesn't look like it's working properly yet, because those numbers don't jive to what I have set up as far as this nav picture. But hey, at least it's there, which means hopefully it's going the right direction. All right, so planetary orienteering. So it's basically which way is north and how do we know what the horizontal coordinate system should look like once we're out of space and we fly back down onto the planets and the moons. So when I say planetary, it means any celestial body that we're going to land on. So basically all that I just said, how do you determine your cardinal directions once you jump onto a new planet? And there's actually, it's by convention, it's that same right-hand rule, like, just said, all of those spherical coordinate systems tend to be right-handed. This is what we mean by right-hand rule. And the way you can, what right-hand rule means is if you take your right hand and just put your fingers together, relaxed, you have a natural curve to your hand when you're not straightening it out or not when you're not flexing it out straight or contracting it into a fist. So when you want to figure out where north is on a planet that you've just arrived at or you're looking at from orbit, the way you do that is you would take your right hand relaxed like that, lay your hand imaginarily on the equator of the planet and let the curve of your fingers follow in the direction of the spin. So if your hand was touching, if you were a giant and your hand was touching the surface of the planet, the friction would be going from your wrist towards your fingers, that direction. Your thumb, just let your thumb stick straight up. Which pole that thumb is pointing at is the one that would be north. So as you can see here on the left, we've got Earth, whose axis of rotation is actually tilted about 23 degrees out of that ecliptic plane we talked about. Uranus is the really weird one because its axis of rotation is almost in the plane of the ecliptic plane that all of the planets are orbiting the sun in. And Venus, people will say, hey, Venus spins backwards, and that's not true. It's still right-hand rule. It's just it's 177 degrees, so it's almost 180 out from the rest of us. So if you were to look at if you looked at the ecliptic plane of the Sol system with all of the planets orbiting the sun, pretty much all of them have their poles, their true poles. I'm not talking their magnetic poles. I'm talking their true poles. Their axis of rotations are all pretty close to perpendicular out of the ecliptic plane, plus or minus a little bit, with the exception of Uranus that's sort of laying on its side and its poles are almost in the ecliptic plane, and Venus, whose north spinning pole is down compared to everybody else's, and its south is up. So that's why people will say Venus spins backwards. It's not actually spinning backwards. It's just its poles are oriented 180 degrees out. All of this is by human convention. See, so like I said, once you find north, you know where south is, and then east is always spinward. So the sun always rises in the east unless you are extremely out of, like, Uranus is very, very strange because of its poles being in the ecliptic plane. So for 1/4 of its orbit around the sun, it'll have a day-night cycle with the sun rising in the east. But then the next quarter, only one hemisphere will have sun for the whole quarter, and the other hemisphere, north-south hemisphere, will not have any sun. And then the third quarter of the orbit around the sun, you'll go back to having a normal day-night cycle. And then the last quarter of its orbit around the sun, the other hemisphere will get sun 24/7, and the original hemisphere that got it will get none. So it's a gas giant on top of that. So you can imagine how crazy the atmospheric, I'll call it weather. Weather's not exactly the right word. The atmospheric currents have to be, considering you have such a strange heating and cooling cycles that go on for when I say year, I'll say for a quarter of their year. Understand Uranus's year is not Earth's year. You're like 1 year, one trip all the way around the sun for Uranus is something like 82 years or something like that for Earth. So, but yeah, this is the conventions of right hand rule determines which of the true poles is the North Pole. From there, you have the South Pole. Into the spin is east. Out of the spin, opposite to the spin is west, by definition. All right, now a lot of theory, so that people are smarter than the average type Star Citizen player. But now we need to actually take a look at how Nav actually works in Star Citizen, and particularly with the new stuff. So one of the things that you need to know is that there's 6 orbital markers around every celestial body. And they have specific positions too, and this is how CIG built this in so that it makes it easier to navigate when you're trying to get around, when you're up close to a planet or a moon and you need to get around it, either to try to land on the other side or because it's in your way and you're trying to fly to something else and you got this big planetary body in your way. So this is how you can get around it, is these orbital markers. They are all 90 degrees out from each other, and they are geostationary and co-altitude for that planetary body. They are not the same. The OMs around Microtech are not at the same altitude above the ground that the OMs around Yella are. But the 6 that are at Yella are all co-altitude with each other as far as how far they are away from the surface. And they are geostationary. The 2 special ones are OM1 and OM2. OM1 is always over the North Pole of the planet. OM2 is always over the South Pole of the planet. So you always know if if Star Citizen is showing you the nav markers, which have not necessarily been the case, but if it's properly showing you the nav markers when you're in master mode nav quantum travel, and they're being displayed properly, which, like I said, they've been missing quite a bit lately. But when they are showing, you should be able to go, okay, look over at that planet with those things up and go, okay, the OM1, that's the North Pole of the planet. And OM2 is the South Pole. 3, 4, 5, and 6 are all over the equator, 90 degrees out from each other, co-altitude and geostationary. So 3, 4, 5, and 6 move. 1 and 2 don't move. 1 and 2 are over top of the poles and they don't move. 3, 4, 5, and 6 are spinning with the planet. They are geostationary, so they are rotating at the same speed that the planet's rotating. So they are sitting over the same spot on the surface. But when we're out in our spaceship out in near orbit, they are actually moving in the direction of east, at the same angular momentum or angular velocity that the planet or moon is. 3 and 4 are on opposite sides of the planet. 5 and 6 are on opposite sides of the planet. That's why if you're at OM3, you look one direction, you'll see 5. You look the other direction, you'll see 6. And to see where 4 is, it's on the opposite side of the planet for you. So you have to point down at the planet, and it should be hiding behind probably the planet's marker as well. So there's another picture of it over top of, I think this is a very, 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 very old picture of Yella, or might have been Lyria. I don't remember where it's from. A million years ago. Okay. Whoops. And yeah, so tying all that together, remember, OM1 is always north. Sun always rises in the east, sets in the west on everything in Star Citizen. Because CR has said that they are not going to do really well. At least, could always change his mind. But at least initially, it said they weren't going to do anything super wacky like Uranus laying on its side. Maybe they will. Maybe they'll change their mind now that Planet Tech has gone way more capable than what they originally designed and planned. All right, so the Nav system. We've got new Nav markers, and here they are. They reduced the number. So they took out they used to have diamonds, and that they had diamonds, and they were kind of the same diamonds for Lagrange points, space stations, I forgot what the other one was. But they basically just make all of those, because there are stations, base station at all those places. Just anything with a space station now has that sort of ellipse with two lines coming out of it. Orbital markers are, the planets are still a circle. Those haven't changed. Moons are now a circle half filled in, is the indicator for a moon. The orbital marker is a circle with a dot. And the cities down on the surface, major landing zones, are now a pentagon, and any other non-major landing zone surface outpost is a triangle. The colorations have not changed, so they will be, if you have a clear line of navigation to them, then they will be whatever the color of your spacecraft manufacturer's company color is. And if it's blocked, it'll be red to say, hey, it's blocked. Okay. They also got rid of the dotted line versions telling you it's over on the backside of the planet. They just went at. So now the say the surfaced outpost diamonds, whether they're on your side of the planet or on the backside of the planet, you can't really tell, except for by range. You just got to look at the range when you kind of hover your nose over them when you're in quantum nav QT master mode. Quantum travel hasn't really changed in the broad, but it has a little bit as far as keybinds. So now pressing B for the mouse and keyboard players, pressing B will switch between master modes. So if we start from the assumption that you're running around in SEM, then tapping B once will kick you over into the nav master mode, and QT sub mode will be the first one that comes up. So you'll so now when you want to quantum travel, you got to get yourself over into nav QT. That will automatically start spooling up your quantum drive. It'll also drop your shields and for some reason turn your countermeasures off. The spool up, the HUD has changed a bit, but the spool up over on the right still is the right curved status bar will start spooling up from below. It also has a sort of a circular arrow, somewhat reminiscent of the Windows wait icon. It kind of sits here and does a little circle while it spools up. When it gets to 100%, now you have enough energy to be able to hop into make the quantum bubble and go. That is called spooled. That is our org's 3-1 brevity word for that is spooled. When you go into nav QT, it brings up the navigational HUD, which really doesn't look that different anymore. It's pretty much the same thing. Next step is then you point at the target, the nav marker that you want to go to, and when the nav marker is within X number of degrees of your gun cross, your nose, in other words, it doesn't have to be perfect, but you have to kind of be in the general vicinity for it to go, okay, that's obviously the one he wants. And it'll start calibrating the nav system for that quantum jump. Same thing. That's the left side curved status bar. And as it goes up, it has this kind of interesting sort of a square with an arrow going out the bottom symbol that sits by it until it hits 100%. When that's 100% calibrated, you're ready to go. That's called ready. So spooled and ready is the call if you're going to be in formation and jump as a group. So everybody set, Aberdeen, 1 spooled and ready, 2 spooled and ready, 3 spooled and ready, and then obviously whoever's flight leading would hit go, and hopefully if sources are running correctly, it'll pull everybody in to a group quantum travel. When it's time to go, it's now left mouse button if you're running keyboard and mouse to initiate the jump. There you go. And then obviously if you're running your own peripherals, it's whatever you set the keybinds to. So setting routes. If you have no route set, when you go into nav QT, then you will get you're supposed to get all of the nav markers that are jumpable for you within any direction that you happen to be pointing. So if you look around, there should be just markers all over the place. If you decide to go into maps on the mobiGlas, which is now the name of the mobiGlas app, it's no longer Skyline. It's never been Star Map. It's just called Maps now. And if you go in there and you set a route, then all other nav markers except for the one you're, if it's a multi-leg route, then the only nav marker that'll show will be on the leg you're flying right now. So if it's a 3-leg hop to get there, then when you set that route, then the only nav marker that should be showing is the nav marker for this first leg that you're about to start. And then when you get to that nav marker, then the nav system should auto increment to the next steer point. So for leg 2, then the only nav marker that'll be showing is that one. And it should just lead you to where you're going when it works. Okay. That selected route nav marker is persistent. So if you are in Nav QT and you come out of quantum travel and you want to just fly to the thing, you can kick your, if you have submodes mapped, you can just kick over into the nav flight submode and it will get rid of all of the spooling sounds and all that kind of stuff and allow you to just fly. But if you have a route set, that one last nav marker that you had up will persist over into nav flight, so you can still see where you're flying to when it works. Okay, I've been last week that I've been going in and playing a little bit here and there. There's been it's 4.0 and later has been a little rough. Okay, so maps, you can shortcut to maps with at function key 2 F2, or you can just go into the mobiGlas directly and then just click maps. It's the 5th one from the left. It says maps and it looks like as far as an icon down there, as you can see on the right. When you click on where it is you want to go, it'll give you the destination info and range displayed in the upper right or left, I think it is. I think it's actually the upper left. And then when you set it, then when you set the route, then you will get the entire nav block over on the right side. The route button will show you within the route button as well, that green route button on the lower left side. You will see your amount of fuel that you have, quantum fuel that you have on board, and then how much that route is going to take. So in this example here, it says something like you've got like 1.1 million units of quantum fuel on it, and it's going to use 745 point something to fly from here to over to Yella. So verify your route legs, fuel required, and time en route in the information on the right. If that all looks good, then go ahead and you can hit F2 to come out of the mobiGlas. Anything that you set in your mobiGlas while you're sitting in your jet, in your seat, will automatically be in the jet's nav system as well. And then you can just simply spool up, align, and go. That nav block info in the over right has a lot of good information. So you got your total estimated time, distance, and fuel and route. As you can see there, it's going to take 0 hours, 0 minutes, 7 seconds to go from. I was just sitting just outside of Seraphim, taking these screenshots. So you can see getting from Seraphim Station over to Yellow takes like 7 seconds in quantum travel. It's 74.59 whatever megacommies, and then out of the 1.1 million, I'm going to use 745.95. Obviously, if this was a multi-leg, then that top line will give you the totals, and each leg would have one of these sort of gray-blue blocks down here underneath, giving you the specifics for that leg. So everything up top should equal the sum of all of the stuff down there. Now, that time is based on the time in quantum travel to get there. So if you have a multi-leg route and at each one you stop and dick around for 30 seconds or 45 seconds, it doesn't know the system can't know how long you're going to take to come out of quantum travel on the first leg and jump into quantum travel on the next leg. So that's a fastest. If you were like able to just immediately come out and go bing bang and get right into quantum travel for the next leg. That, that's what that number is. So take that number going like, okay, you might take another 30 or 45 seconds depending on how fast you can make those transitions between legs. All right, so wrap up. OM1's always north. OM1's always north. OM2 is always south. 3, 4, 5, and 6 are over the equator. If a nav marker is red, it's blocked. Everything else means you should be able to get there. You set routes and maps in the new thing. Make sure you check your QT fuel before you jump. Otherwise, you may get a rude awakening when you get like half or 3/4 of the way to wherever you're going. And remember that those distances in Pyro are pretty gross. Yes, they beefed up all of the fuel tanks in across the entire fleet in Star Citizen so that people would have less problems about this, but you can still manage to run yourself out of gas. And yeah, there you go. For the 3-step quantum travel process, get into Nav QT master mode. That'll spool things up. Aim at your nav marker. When you're 100% spooled and ready, then left mouse button, off you go. Questions?
I got an addition, Fog. I don't know if it was covered.
That
the icons at the top right, the diamond will bring up your missions, and you can click on them, and that'll route it for you. Did you cover that?
I did not.
Okay, and the one below it, like a teardrop, that'll show your friends in the party, so you can nav right to them and not have to try and separate them.
Cool.
And the other one with the ship around the planet, I can't remember what that does. I heard it on YouTube.
Huh. Awesome. Yeah, so they've added shortcuts into maps.
Yeah, and they actually work, and they're preferred
places.
to use like for missions and stuff. Just click on it, the one you want, if you're stacking them, and it'll route it for you, and you just have to accept it.
Cool. Awesome. Good gouge.
And it works. So I haven't had a problem with it.
All right. Any other questions or comments? Going once, going twice. All right, that wraps up this installment of Academics of Foghorn. Hope you found it interesting and helpful. If you have any questions I didn't answer, please feel free to contact me via emails, Discord, Spectrum, or of course the comment section below if you're watching this later. I'll answer it to the best of my ability as soon as I see it. Please hit those follow and subscribe buttons as appropriate. Comment your comments in the comments, and you can find out more information about the Aurora Republic at our bespoke website, aurorarepublic.space, or on Spectrum at robertspaceindustriescom/org/AuroraRep. See you next time. Foghorn signing off, wishing you a very pleasant remainder of the remainder of your morning, afternoon, or evening. Thank you so very much for watching.